Guys, welcome to Crypto Pluto, the channel where we discuss cryptocurrency trading the right way. So, as we said before, this channel will be divided into three parts. The first part will talk about technical analysis, how to look at charts and decide when to buy and sell a cryptocurrency. The second part will pick a coin, review it, discuss what aspects to look for when deciding to invest in a coin, and then the third part will learn solidity programming. Starting February, every month I'll be giving away $50 worth of free Bitcoins to one lucky subscriber. To enter the contest, you have to subscribe to this channel and leave a comment in any one of my videos with your Bitcoin wallet address. So, today we will look at the ERC20 token standard. We hear a lot about ERC20 tokens, ERC223 tokens. Well, what is it? Well, the ERC20 standard is nothing but a protocol that when you write a smart contracts, you have to have certain functions and you have to name them in a very specific manner. And the reason why this is done is because when someone else interacts with your contracts, he knows if your token is a fully ERC20 compliant token, your token will have certain functions in them, and he will know exactly what the name of those functions are and how to call them and what purpose they'll serve. Say for example, you have to have a function called total supply, which will basically return the total supply of your coin. So if someone wants to interact with the smart contract and wants to know the total supply of your coin, they will just call this function, and it has to be spelled in this exact same way. So it has to have 6 functions, 2 events. Now, what are events? Events are when something happens on your smart contract, it only gets logged. That event only gets logged on the Ethereum blockchain once an event is triggered. So, say for example, a transfer of token has taken place. That transfer won't get logged in the Ethereum blockchain as long as the event is not triggered. And then you need to have 3 variables. So once you've done that, your cryptocurrency is fully ERC20 compliant. Unlike last time, I decided to change these things up a bit and decided that I will have the code pre-written and then we will discuss the code line by line. That will save us a lot of time. So let's start. Okay, so we are modifying my coin. We have these 3 variables. The name, the symbol of the variable will be my MYC, and the name will be my coin. Sorry, that was a mistake. Okay, and then the decimal, what the decimal does is, so the decimal shows how many of the smallest denomination make up the bigger cryptocurrency. Say for example, the smaller denomination of Bitcoin is Satoshi. The smaller denomination of Ethereum is Wei. So the decimal, if the decimal of Ethereum is 18, what that simply means is that 1 followed by 17 zeros, total 18 digits, that many ways make up 1 Ether. So for this, say for example, 1 followed by 18 zeros, that many my coins will make up 1 mega my coin or something. You get the idea. The standard is 18. It could be 3, it could be 5, whatever you want it to be. However you would like to break up the denomination. With fiat currency, it's basically 100. So say for example, 100 cents make up $1. So the decimal would be 3 for fiat currencies. Okay, so then you need to have a constant, an integer named. You don't need to have this. This is outside the ERC20 standard, but we have this here because we want to have the supply as an integer, and we want to have the supply fixed. So once you declare a variable, before writing the name, if you write constant, that means it cannot be changed, and we don't want the supply to be changed. So we wrote constant and then supply and then the amount, which is 1 million. So 1 million of these tokens are available. Okay, so now, like we did before, we have a mapping. So every address has an integer attached to it, so which shows the balance. So every address has a balance. We have So with the ERC20 token, one thing you can do is you can allow someone else to spend money from your account. So for that, we need every address to have another address. This address can spend money from my account. So every address has another address attached to it, and that address has an allowed amount attached to it. This means that address can spend up to the allowed amount from the donor's address. So this is a double mapping. And guys, if you have done programming before, if you have done multidimensional arrays, dictionaries, this shouldn't be very complicated to you or unfamiliar to you. Okay, now we have the constructor, and in the constructor function, whoever calls the smart contract, he gets all the initial supply. And this makes sense. Say for example, you're making your own coin, you initially hold all the coins, and then people, say for example, invest in your ICOs, and you distribute the coin amongst them. So the total supply is equal to the balance of the message.sender. The message.sender is the person who triggered the mycoin function, the constructor function. So the person who created the smart contract will have all the tokens. Now let's come to the ERC20 standard. The total supply will just return the integer, the unsigned integer supply. Okay, so if someone calls the total supply function, they can see the supply available. The balance of function, the next function, the balance of function will show the balance of a certain address. So if someone calls the balance of function and supplies an address, the balance of that address will be returned. Okay, pretty simple so far. Okay, now we have the transfer function. We'll get to the allowance function later, or let's get to the allowance function first. Okay, so what the allowance shows is, remember I told you that some people are allowed to spend from other people's accounts. So what the allowance function does is that it takes two addresses and sees if the second address sees the amount that the second address is allowed to spend from the first address's account. So what the allowance function does is takes two addresses and then sees if the allowed. So remember we did the double mapping, we named it allowed. Okay, so if the spender, the amount of money the spender is allowed to spend from the owner's account. Okay, so that's what the allowance function does. And then we have the transfer function. So what the transfer function does is you can transfer money from one account, from your account to another account. Okay, so here we need to make sure two things. One is the amount you're trying to transfer is not a zero. So you want to transfer real tokens. You don't want to transfer zero tokens. So the amount you're trying to transfer has to be greater than zero, and the balance of your account has to be greater than value. So you can't have 50 tokens and you try to transfer 100 tokens. So the balance of the guy who triggered the transfer function, his account is message.sender, so his balance has to be greater than value. So if that condition is fulfilled, the balance of the person who is transferring the money, his balance gets deducted by the number value. This is what minus equals basically means. So if I have, and guys, if you're finding this a bit confusing, watch the first video in this playlist and trust me, this will become much clearer. So what minus equals really means is that it subtracts the value on the right hand side from the value on the left hand side. So it subtracts value from balance of message.sender. Okay, so say the message.sender is trying to send 20 tokens to an account. He has 100 tokens. So his balance will be 100, and then value, which is 20, will be minused from his account, will be subtracted from his account, and then his new balance will be 80. Okay, now the receiver, whose address we refer to as 2, the receiver's account will be added with value. So say the receiver had 50 tokens, now he will have 70 tokens. And so the transfer has happened, but it hasn't been logged on the Ethereum blockchain. And for that, we need to call the transfer event. and we have declared the transfer event here already. And what the transfer event does is it takes two addresses, the sender address, the receiver address, and the value, and then it logs this information in the Ethereum blockchain that the sender sent this much amount to the receiver. Okay, and then if this condition is fulfilled, this function returns a boolean, which a boolean is a variable which can either be true or false. It's not an integer, it is a true or false variable, so it can either be true or false. So this function returns boolean true if this condition is true. If this condition is true, that means these three lines got executed, that means the transfer happened, it means the transfer was success, it was true. Otherwise, obviously the transfer didn't happen, and then it will return false. Okay, now we look at the next function, which is approve. So what does the approve function do? The approve function approves someone to spend a certain amount of money from my account. Okay, that is what it is meant to be. Remember, these functions, you can have them do whatever you want, but this is what the purpose of the function is supposed to be. So what the approve function does is that it takes an address and then approves that address to spend a certain amount of tokens from my account. All right, so but we need to have certain checks in place. First of all, the person who is trying to approve another person to spend money from his account, he's the message.sender. His balance has to be more than the amount of tokens he's allowing the other guy to spend. So if I have 100 tokens, I can't allow someone else to spend 200 tokens. So the balance of the message.sender has to be greater than value. And then it doesn't make sense if I approve someone to spend 0 tokens. So it has the value, the amount I'm allowing that person to spend has to be greater than 0. If that happens, then the message.sender allows the spender, so the address of the message.sender allows the address of the spender to spend the amount of value whenever he wants. So his allowed amount is now equal to value. Okay, now once this is done, this event has not been recorded on the log, it has not been logged on the Ethereum blockchain yet. So we have to call the approval event, and then what the approval event does is that it takes a donor address, and it takes a receiver address, and it takes a value, and logs that information onto the Ethereum blockchain, saying that the donor has allowed the receiver to spend this much money on his behalf. It doesn't work like that. Basically, it just logs these three information onto the Ethereum blockchain, but you get the idea. And now, so if this if statement is true, that means these lines have been executed, that means approval has been done, so it will return true. Otherwise, it will return false. Now, the last function, which is transfer from. So what transfer from does is that, so I already have permission to spend someone else's money. So I want to transfer some money from his account to someone else's account. How do I do that? So to do that, I will this function will first take whose account I want to spend money from, whose account I want to send the money to, the tokens to, and how much tokens do I want to send. Okay, but for that we first need to have some checks and balances in place, and these checks and balances will be the following. Let me align it better. Okay, great. So the person whose account is being used to send money, we need to see that if he has allowed the person who's trying to transfer the money. So the message.sender, we want to see that if he has allowed the message.sender to send any money in the first place, he has allowed the message.sender to spend any money in the first place. So we have to see if his allowance is greater than 0. And then we don't want him to spend, to just transfer 0 value. So we want to see if value is greater than 0. Then we also want to see if the person is allowed to spend, so say the person is allowed to spend 50 tokens, but he's trying to transfer 100 tokens from the account to another account, from that account to another account. That can be allowed. So we have to see that if the person who's trying to send the money, if he is allowed to spend that amount, more than that amount of money, or equal to, at least equal to that amount of money from the donor's account. So we want to see if the donor's account has allowed the message.sender to spend at least a value whenever he wants. And then we also want to see that even though the donor has allowed the spender to spend 100 tokens, but right now the donor doesn't have 100 tokens. We can't allow that. So we have to see if the balance of the donor account is greater than the amount of money that is being trying to send. If all these conditions are met, then the balance of the donor account will get subtracted by value, and the balance of the receiver account will get added by value. What this has also done is that now the spender is allowed to spend less money because he has already spent some of his quota. So the the allowed balance will be subtracted by value. So now the transfer has taken place. But this hasn't been logged on the Ethereum blockchain. So we would do that by triggering the transfer event, and if all this has happened, we return true. Else, if this condition is not fulfilled, that means what this double AND does, that it makes sure that every single one of these 4 conditions has to be true. If even one of these conditions isn't true, these lines won't be triggered. So when all 4 of these conditions have been met, these lines have been triggered, we will return true, else we will return false. This is it, guys. This is an ERC20 token. 2 things I want you guys to realize is that, one, it's not rocket science. Anyone can do it. It's quite simple. And what a lot of the times happens, especially in Ether Delta, is that this is a bare minimum ERC20 token. It doesn't do much. So what happens a lot of the time is that people make a bare minimum ERC20 token and then they try to sell it on Ether Delta, and a lot of the times it's just scam. One such currency I know of is Dino. Their website is dinoempire.com, and what they do is total scam. And another reason why it is really important to know these programming languages is that then you can actually go to their GitHub and see if they're worth anything. A lot of these cryptocurrencies are just rip-off of other cryptocurrencies, and once you know this, once you understand this, it's so easy to identify the flaws and identify whether or not it's a scam. So guys, please be careful and use this knowledge to actually assess the potential of a cryptocurrency by looking at how it works under the hood. Thank you very much. See you guys next time.